Okay, so hi, my protein is ribulose biphosphate carboxylase, or Rubisco for short. And honestly, when I read my protein, I was not excited because I thought this mouthful was going to just be nothing all that interesting, but actually starting to research, I figured out that it's very interesting. It's actually super important uh, for the world because it's the catalyst for photosynthesis. But as my article that I'm going to talk about says, it can also catalyze photorespiration, which is where it gives off O2 instead of CO2 in plants, and it's not as energetically favorable. My article was written by H. Ager, R. H. Wilson, A. Breaker, L. Calise, J. Y. Bott, U. F. Hartle, M. Hayer Hartle, and that's the scientist, at the Max Planck Institute of Biochemical, in Martin-Schried, Germany. Okay. So like I was saying before, Rubisco is the catalyst of photosynthesis, but it can also catalyze photorespiration, which is less energetically favorable. So basically, in an effort to improve, to make agricultural improvements, for a long time scientists have wanted to try to isolate Rubisco, and try to figure out how they can make it more functional so that they can get more crop yield, or you can just improve plants in general. But from an agricultural point of view, you can utilize the different amounts of, the different things that you can do with Rubisco in order to make it favorable to whatever you're trying to grow. So like, if you're trying to grow corn versus soybean, you might have different strains or different, I don't want to say strains, but different little things that are different subunits in each one that make each more favorable. So that's why they wanted to try to figure that out. The title is Plant Rubisco Assembly in E. coli with 5 chloroplast chaperones, including BSD2. So what they did was they took the 5 chloroplasts and the Rubisco proteins, and they put them into E. coli. And in this E. coli, they were able to figure those things out and utilize it more because it's been very hard to try to study Rubisco in a plant. So basically, they put it into a bacteria because it's a lot easier to manipulate. I just found this really interesting because they are doing it for agricultural reasons, and I'm an animal science major, so I'm kind of into the agricultural side a little bit. And I think it's just something interesting that I can use in my paper towards the end. One of those last paragraphs where you can talk about the different unique properties of your protein. I just think that it would work out very well there, and I can build on it because I have seen a couple of other articles that are also very interesting when it comes to Rubisco. So I'm very excited for this paper, actually, and I don't like writing papers, so that's really good for me.